Classification say yes, no, or 1, 2, and there are multiple classification level. That means graded values or ranking. In case ranks comes under the graded classification levels. That is rank 1, rank 2, rank 3, rank 4, likewise. So these are some of the measures what we also make use of while determining the customer classification types. So we use data analytics tool as a means to achieve these objectives. And our current presentation focuses on the classification and predictive modeling technique called random forest. Now we come to the machine learning because, as I said earlier, because random forest is a tool for machine learning because it is making it makes a lot of techniques and measures of machine learning are used into these techniques as well. And I'm quoting Bill Gates' a quote, very thoughtful quote: "A breakthrough in machine learning would be worth tens of Microsofts." So that is where you can just imagine the importance of machine learning that is happening now. Machine learning is also part of AI, artificial intelligence, as you may know. So what is machine learning? It is automating automation and getting computer programs to do themselves program. And writing software is a bottleneck because it's a hassle for most of the people. Of course, those software engineers, they may be feeling a bit unlucky to see this one because software is the bottleneck because they do not want them. So it's all machines are likely to do that one. So let the data do the work instead. So random forest is one such technique of machine learning. Now, I will give you some sort of types of machine learning what we have. So what do you mean by machine learning? So what are the types what we have? So the first one is that supervised learning. This is the first type, what we call it as supervised learning. It has subnodes like, say, for example, regressions, classifications, or the subtypes of supervised learning. I will explain about what is supervised learning in the subsequent slides. So please bear with me. So it's just an outline of the machine learning what I'm trying to show you. And I have another type is called unsupervised learning. It has clustering as well as dimensionality reduction. And the third one is reinforcement learning. So this is the types of machine learning. And I will explain now what is supervised machine learning. In a supervised learning, you imagine that there is a model or a brain is there. And for that model, you are showing some grapes to that one. And you are telling that these are grapes. Now what the brain does, it understands, okay, see, this is the shape, this is the color, this is how it looks like, and it has been named as grapes. Okay, now we have a software classifying model, the classifying algorithm is developed, and it is being used for learning because in case a new grape bunch is taken and shown to the software, that is the classification model. So it has to tell what is it on the basis of the learning what it has done. So it has to predict what is this item. This is not part of this one. It can be an apple or it can be some pineapple or something else. But here, of course, for the sake of convenience, we have taken grape. And what we are expecting, in case if it has learned correctly, it should give the names correctly. Okay, so it's saying that it is grapes. That is the prediction that is being. So that is what we are trying to make use of supervised learning. So we know certain things and we also know its class to which it belongs, whether it is grape or apple or such. So it is very clearly known to us that it is grapes. Now that information is being transmitted to the model, and model is trying to pick, in case if there is a new instance comes up, another grape that is taken from some other, it is not part of this one, it is outsider, and we are trying to ask this, what is this? Can you predict what is this? So it says that it is grapes, it is prediction. So that is how the supervised learning is processed. Now we talk about unsupervised learning. So again, similarly, so in unsupervised learning, we have a set of inputs that is not classified, or its information is not known to us. Whether it is avocado, whether it is orange, whether it is apple, Of course, absolutely no idea, but they have been randomly allocated. So some random picture is shown to the model. So now what we want from the unsupervised learning, the model should be able to cluster them into homogeneous groups. Apples should come together, avocados come together, oranges come together. So this is what is unsupervised learning. So methodology or the tool will be able to develop this kind of techniques to cluster them into homogeneous groups. Now, how this unsupervised learning is being used in a practical sense, I will just give you an example here. Say, for example, we have to identify the potential customers for selling a particular product. And so we are using the unsupervised learning, and you are clustering the customers on the basis of certain characteristics. Because here you can see there are certain characteristics for avocado, how it looks, its color, and orange, it has its own color and shape, size, and apple, it has its own color, shape. These are certain characteristics of that particular item. So similarly, we identify certain characteristics for those customers and group them on the basis of certain homogeneous groups. Homogeneous characteristics for these particular groups are identified, and we are classifying them into different set groups or set of customers. And we try to identify which particular group of customers are likely to buy our material. So selling that product to them after the identified group of customers have been known to us. So that will make business a success. This is how we are going to make use of unsupervised learning. Now there is a third one. Third learning is about reinforcement learning. So there is three types of strategies are that way: user, agent, environment. So information is passed on, it will be reformulated, it will be aggregated, and again it will be reinforced. So this kind of reinforcement is taken, and this information is mostly found when you are Googling. Actually what it does is Google's active query answering is AQA. That is, a system makes use of this reinforcement learning is being made use in certain situations. It is not commonly used in other industry level, or what I haven't seen these kind of things happening there, but slowly it is getting picked up. Only the first two, that is the supervised learning as well as unsupervised learnings, are the most common. Reinforcement learning is not that common. Only very high advanced analytics team are making use of, say for example, Google Analytics, they are using this one, active query answering. And also Facebook is using this information as well. Now, so all said and done, so every technique as well as tools have its own positives and negatives. So this is one of the issues with the machine learning tools as well: bias, variance, trade-off. I don't know how many people are aware of the term bias as well as variance. Variance, of course, mostly engineering students must have had got some information about variance when you have learned about statistics. And bias is nothing but it is a sort of a mean value. What we are doing is we are making a prediction and coming up with a mean value, and we have an original mean value on the basis of observed values. And we are comparing these two mean values, that is observed with the predicted one. And if the differences are very small, we say that the bias is very small. When we talk about variance, it is how far this mean value is spread. So mean value, when you are taking, because it is not on the basis of some 100 or 200 or n number of values. So what is the range? How is the spread of these values? How close these values, maximum as well as minimum value, how close they are to the mean values. That is the spread, what we call. So that is the variance. So when we say low bias and low variance, that is what we are trying to achieve using the machine learning algorithm. But the problem is that is a naturally occurring problem in any data set, is that if you want to increase the bias, it will decrease the variance. If you want to increase the variance, it will decrease the bias. So this is the kind of balancing kind of things you have to do. So what machine learning is doing to balancing as well as the trading of the bias variance. So that is the main objective of machine learning algorithm. So there are certain machine learning algorithms, they have high bias by nature. That is a linear machine learning algorithm. Say, for example, regression analysis and logistic regression and all this kind of linear machine learning algorithms, they have high bias but very low variance. At the same time, non-linear machine learning algorithms, they have a low bias but high variance. So these are some of the scenarios that is present inherently within the data set. So that is to be converted. So that is to be taken care of while using any of the machine learning tools. Now comes to the decision trees. So what is the decision tree? Why we are making use of this? So in order to understand random forest, we have to understand what is a decision tree, because random forest is nothing but a collection of decision trees. So that's why first we want to know what is it and how it works. Now I will give an example of how the decision tree works. So there is a question: shall we play tennis today? In order to answer this question, we have a set of information available. So this information tells about, this is the collected real information, that is for different days. The outlook has been taken into account. So it was a sunny day, the temperature was hot, and the humidity was high. I'm talking row by row. And the outlook, temperature, humidity, wind, and play tennis are the columns. So I will take the first row. So D1, it is outlook is sunny, temperature is hot, humidity is high, wind is weak. Then whether to play tennis or not is the question. The answer is no. So likewise, you can see for different days, this kind of information has been given, that is input variable, and the last column is the output variable, that is a decision variable. So this is an object. It's a example from a lot of, so much of information has been collected on this one for different days, but it is only a sample of that one I'm showing. And we have humidity, wind, temperature, outlooks. These are all called attributes. They are also called variables. And the property is whether to play tennis. Now, what decision is being taken on the basis of this table is that the play tennis column is the decision column, and also called as class label. In any decision tree, we have to understand some of the commonly used terms. That's why I'm using here. Okay, now we will build a decision tree using that table. Okay, now outlook, we have three values for an outlook. That is, it may be outlook is sunny, outlook is overcast, or outlook is rain. Now we have two more attributes, that is humidity and wind. So humidity has a value, high value or normal value. Wind has a value, strong or weak. Now we can take a decision, because this is where we are going to take decision. So how to read this one, that is what we are going to talk about in the next slide. So now the data has 5 attributes, that is outlook, humidity, wind, and also the outlooks like no, yes, these are the decision nodes. So based on the training data, I will also give you some idea about the training and test data in subsequent slides. So until that time, please bear with me. So based on the trained data, we want to find a set of rules to know what values of outlook, temperature, humidity, and wind determines to play or not to play tennis. So that is what we are trying to make use of this information. So now why it is called a tree? Because in case if you keep this figure upside down, you can see that it is branching or going up. So it is the outlook becomes a root node, and all other things are going upwards, so as a branch. And yes, no kind of decision-making nodes are called leaves. That's what I'm going to explain here. So these are the humidity, wind, outlook are the attributes, and outlook is the root node, and humidity and wind are attributes, subnodes. And the weak, strong, this kind of information, that is for each of the attributes, I have some values, that is called value. So these no, yes, no decision nodes are called leaf node or class label. This is how it has been defined in a tree. So now you have to revert it, that upside, keep it upside down and see that it looks like a tree. That's why it is called a decision tree. Now how we are, when you reach a point where no proper splitting is done, because the splitting, this is called, we call it as a splitting. There are two values it has. So we are splitting this node into two, and it may not be the decision node here. So it may be something else, some other characteristics or attribute comes here, and we may have to further split it. And further, there may be another node comes up, because this is a very small, simple exercise we have taken. So that complexity is not found here. But in reality, when you deal with the real data, so this is not the situation. It may be very complex. In such cases, the decision tree has problems. When you have large number of branches, it will not perform better, because there will be a lot of issues that what we are going to talk in the subsequent slides as well. So in case if you are, when you reach this particular further split is not possible, then we call it as a leaf node or a decision node. Now, how to develop the rules? Because a decision tree is given, how are we going to take the decision? So what are the logical expressions we are going to use, or the rules what we are going to express? Say, for example, if outlook is sunny, and humidity is normal, then we take a decision to play tennis. Similarly, if outlook is overcast, that's fine. So we can play tennis. If the outlook is rain, wind is weak, then we play. Yes, we play. If outlook is sunny, humidity is high, and we don't play, no play today. So that is how we take the decision. This is some of the rules. So these rules, this has been given in a very simple sentence, but we will be using certain mathematical way of putting this one. There are formulas to develop these decisions, and these rules have been implemented into the machine learning algorithm, and we are making use of that algorithm to find out, in case if a day is given outside the table. Say, for example, we have about a D1 to D14. In case if you want to know whether we want to play on day 15 or day 16, so that is the new information, that is new instance that is coming up, where information is not available so far, but we are asking the decision tree to learn from the known information and transfer that information to take a decision for the instance that is outside that range. So that is what we are trying to do. So on the 15th day or 16th day, what is that decision we are going to take? On the basis of certain outlook, humidity, and wind information is given. So what is that decision we are going to take? So that is how the decision tree works. So why we are using decision trees? So that is what I was talking about. Learn from known instance. That is, we have instances for D1 to D14 days, and how to classify unseen instance. That is the 15th day. What is the, that is the unseen instance which has not been used for learning purpose, machine learning purpose. So we want to make use of that information that has already been collected by the machine learning module algorithm to see that whether we can classify an unseen instances. So that is one of the advantages of the decision trees, why we are using the decision trees. So it enables the business to quantify the decision making. So it is always the decision making process. So the business can take decision whether to do or not to do kind of things. So when the outcomes are uncertain, because when we are absolutely no idea what is going to happen, in such cases, these decision trees are going to help us to take a proper decision. Of course, the decision is not just a binary, yes or no. It may be multiple. There may be 3 or 4, because, okay, sometimes we can, it's perfectly okay. So likewise, we have different qualifying classifications also. So we need to be aware of the kind of instances that we are coming up, what is the decision we are going to take, and what is the right decision for a particular business or company to take. So that all these type of classifications are depending upon their requirements. So it also allows comparison of different possible decisions to be made, because you have a number of options there. So because in case if this is a situation, this is a decision, and the scenario changes, the decision can be different. So if given this second scenario, this is the decision. So likewise, you have a possible decisions combinations are there to be compared. So these are some of the where we are going to use the decision trees.
So Akash here.
Sorry.
So can you just click the hide button on the slide, because some of the students are saying that the bottom lines are not visible.
Sorry, I can't hear you properly. So what is that you want to know? So is it something problem with the audition or something like that?
So there is a pop-up video. Meet Google is sharing your screen. So that is hiding the bottom lines. That's why it's in your
Oh,
screen.
right. Okay. So you want to hide it?
Yes, sir. Yes, sir.
Okay. Okay. Right. Okay. Okay. So advantages of the decision tree is that it is very easy to interpret, but you have seen that how we can find out whether to play or not to play by just going through the different branches. So it applies to both categorical as well as numeric data. So because your data can be categorical, when I say categorical, you just understand that it is something like a qualifying, because the color, that is yes, no, all right, or it is a good, bad, the better. These are some of the qualifying categories. And numeric data can be ranks, it can be numbers, it can be numerals, so anything possible. So the decision tree has the advantage of using any kind of data variables. Data values can be categorical or numeric. Because assume that in case if you are running a regression equation or regression modeling, then it will only accept numeric data. It doesn't accept categorical data. But whereas in logistic regression, you can use both categorical and numeric. So that is how the difference is between categorical and numeric. I'm just trying to explain you what does it mean. And in case if you have outliers in the data, so these decision trees are not going to be affected by the outliers. So it is very robust against outliers. And this classification is very fast. Once rules are developed, it can be run very fast. So the decision algorithm, classification algorithm using decision tree is very fast, provided the rules are very clearly and explicitly explained. So what are the disadvantages? So the disadvantage is that there is a concept called overfit. I'll be talking in the next slide what is overfitting. So this overfitting can give you poor results, not possible to predict beyond the minimum and maximum limit available in the training data. So now in the training data, we have seen some set of data, but in case if any information that is coming outside this training set, say for example, outlook, we have 3 scenarios: sunny, overcast, as well as rainy. In case any other scenario that comes up that is outside the training set what we have, in such scenarios, the decision trees are not going to work better. So that is one of the disadvantages of decision trees. And when you have large number of the data, the decision tree is not going to work. As I said earlier, you see the branches will prop up at every stage. So there will be umpteen number of branches. So it is simply not possible to handle. Decision trees can't handle that kind of scenarios. That is one of the biggest disadvantages of decision tree. It is okay for small data set and very small businesses or small companies, it can be. But when it comes to large, huge data set, because that is what we are looking that, because so much of information that is bombarding every day, so much of information that is coming, the decision trees are not going to work in such a scenario. Okay, so what? How are we going to deal with it? So that is what we are going to talk about in the subsequent slides. So before then, I will give you some of the idea about what is overfitting, what is underfitting, and assume that, you see, we have a graph here showing the horizontal scale shows the number of nodes. When we talk about node, you just imagine how many nodes we had in that decision tree, that is a playing tennis. We had about 2 nodes. One is root node. Humidity and wind are the 2 nodes we are using. So likewise, number of nodes, because when we are dealing with the practical data, there may be number of nodes, because as the number of nodes increases, the horizontal line shows the percentage of error that we are going to by fitting the data. So how much of error that is we are going to commit. So that is shown on the vertical line, and the number of nodes are given on the horizontal line. Now, there are 2 types of data set what we are using. the training set as well as test set. So training set is the one which you have seen for playing tennis, the data that is given there, the table that is shown there, that is a training set, because the machine learning model or the algorithm making use of that particular table and collecting information. Now, test set is the one, the instances that is coming out of that particular training set, not coming out of that, so which is a totally outside that one. So for example, in the supervised learning, I have shown you the grapes, some 3 grapes are shown there, it is to learn. And another set of grapes or fruits are taken and shown to the model and asking it to predict it. So that is totally outside from this 3 grapes box. So that is what here the test set is doing. So test sets is totally different from the training set. It is coming from totally from outside. So using the training set, we are trying to understand the characteristic and we want to apply that model and also the prediction rules to the test set and see that how far our prediction is going to right. So in such cases, we have to measure certain parameters. That is, one is the error percentages. So what happens in the training set, if you have large number of nodes, the error goes down. But you are applying that classification algorithm to the test set. What happens? The error percentage is going up. After a particular point, it keeps going up in the test set. That means your error rate is very high. That means your predictability, your ability to predict correctly has gone wrong. So we have to have some sort of a cutoff, I think somewhere here, so that is the maximum point what we can have. So this is the likelihood of having number of nodes that we can make use of. So beyond that, it is going to be erratic. Your prediction is going to be very poor. So this is one of the disadvantages of the decision trees. Now I will tell you what is underfitting. When the model is too simple, when I say model is simple means number of variables. Say for example, what we have playing tennis, we have hardly some 4 variables. So that is a simple model. Both training and test errors are large. It is both, you can see that number of nodes when it is below 50, both training as well as test set, they have a large error. But under overfitting, when the model is too complex, when I say complex model means large number of nodes, because here situation is very large. The training has small error, but test set has high error. So this is one of the disadvantages of the decision trees. So what? So what it actually does is learn the data, but not the underlying function. That is the problem with the decision trees. It performs well on the data used, because in case if you are using the information from the same training data, it performs very well. So there is absolutely no problem. But when you bring data from outside and ask it to classify it, it will be a poor fit. So that is what it's all about, overfitting and underfitting. So this is some certain scenarios where underfitting and overfitting is shown here. See, underfitting, when we know that the distribution is something like curvilinear, but the model is fitting it as a linear. So this is underfitting. So it is just right. It is a curvilinear, and our model is also saying that it's a non-linear. So that is just right. And overfitting is, it is a very ambitious, and it is trying to cover all the information available in the data. But if you are using this model to predict an outside instance, it is going to be a problem. It's a poor fit. So this is where the problem comes with the overfitting. So this is another scenarios I'm trying to explain the problems of overfitting and underfitting. So in order to solve this problem, we have random forest. So I will give you a brief introduction about random forest this point onwards. Before then, I will just want to show you who are the developers of these random forest techniques. So it was first introduced by Leo Breman in 2001, although the algorithm was developed during 1995, even 92, in fact, because I have a paper that is on 92. They have been using this random forest related information. And it is a published form, and in a very developed form, it has been published only in 1995 as a random subspace method, but it's not as a practical classification problem until 2001 when Leo Bremen took up and came up with the paper. So this is the starting point of random forest. That means it is pretty new. Okay, what is random forest? Okay, random forest is a classification algorithm you have seen in decision tree, consisting of many decision trees. It is not just one. Thousands and thousands of decision trees are made use of developing the random forest. So this is also called ensemble method. Ensemble means assembling the information from different decision trees. So ensemble classifier using many unpruned decision tree models. So pruning and unpruning is one of the terms that we generally use in decision trees, because pruning is, as I said, if you go on developing the branches, we never come to an end. So that's why in such scenarios, we will prune the tree. By pruning means we are not developing further branches, and we are trying to take a decision after pruning, after second level or third level or fourth level or whatever. So that is called pruning. So that is one of the techniques what we use in decision trees, just to prevent unwieldy development of branches. So, but in random forest, that problem do not arise, because we are using unpruned decision trees. So we need not have to do that kind of pruning in these decision trees. We are using just randomly whatever number of branches comes up, that's fine. So we will be collating all these decision trees and coming up with the ensemble classifier. So I will explain you in the next slides a simple form what I am talking here. So this is just to give an understanding outline of what it is all about, ensemble method. Each base classifier classifies a new vector. I will explain in the next slide as well. Random forest chooses the classification having the most votes. What it does is, it has number of trees, number of decision trees. From each of these trees, there are number of decisions are taken for each of the decision nodes. So that means if you have n number of decision nodes for one instance, say for example, we were talking about in the decision tree playing tennis, outlook is sunny and the humidity is weak, we play. So play is the decision. Now that is on the basis of one decision tree. But here we are using thousands of decision trees, and some of the decision trees may say that no, some of the decision trees may say that yes. So now we have a vector of decisions for one instance. So we will collect out of this one, we will go for a majority voting. So how many of them out of 1,000 have voted yes? So in case if it is above 60% or 70%, so then we will set up a cutoff point and say that, okay, above 70%, in case if it is yes, we will take it as yes, that is the decision. So that is how the random forest works. So it is a simple form I am taking, because this is a simplified form of in a visual forms how we are going to what I have been explaining previously. So I am going to explain here. So there are tree 1, tree 2. So likewise, n trees are developed. For each of those trees, there is a decision for one of the cells. Say for example, one of the nodes is a decision nodes is there. That decision node is saying that it is a class A, because this is being classified as class A. And in this decision node, it is B. And in this tree also it is B. So now on the basis of majority voting, we are going to select the decision for this instance as B, because majority of the nodes are saying that it is B. So that is what you call it as majority voting. So this is where the final class is determined. You have seen the table where the decision is taken yes, no kind of things. So that is called final class. So final classification is done on the basis of majority voting. This is all about the simplified form of random forest. So what are the advantages? Overfitting is not a problem. No need to prune trees. Not very sensitive to outliers. Very easy to set parameters. When I say parameters, means number of trees to be developed, number of nodes to be developed, and number of iterations you have to go through. So these are very easy to set these parameters. Disadvantages: can't predict beyond the range in training data. That is also one of the problems, because in case if you have some values that is outside the range, so its prediction is not very good. But it will predict, but it is not very accurate. The estimates are not going to be very accurate. That is the only problem with the random forest. It can handle very large data set, absolutely no problem. And it is very efficient and very accurate. Now, see, there are different methods of combining the information collecting from the different trees. Say, for example, I was saying that the decision is taken on the basis of majority voting. Now, there is a methodology involved in collating that information, combining that information, and that is what we call as combining decision trees. So here, there are two techniques that we are using. One is bagging and boosting. So bagging is training a bunch of individual models in a parallel way. Each model is trained by a random subset of the data. So when you are talking about in the previous slide, you have seen the number of trees, but each of these trees are selected by randomly selecting the samples from the data. And also the nodes, number of variables we have seen in the tennis, playing tennis data, about 4 or 5 variables. So in a decision tree, we are making use of all the variables, but in random forest, we'll be randomly selecting the variables. Not all the variables are going into every tree, because we are dealing with a huge data set having number of columns, maybe 100, 200, 300 number of columns are there. So we cannot make use of all the variables there. So we will be randomly picking up, and we are trying to develop a decision on the basis of this randomly picked number of variables. So that is again an advantage, that we can find out the importance of variables. That is, as part of the, as a byproduct of random forest research, importance of variables can also be predicted. So the boosting is as you are using in the gradient boosting machines, because gradient boosting machine is also something similar to random forest and deep learning. So these are some of the machine learning tools. So boosting is something similar to that one. The definition of boosting here is when we have a weak classifiers. So when you are combining the weak classifiers, they will try to boost the model. That is what is meant by here boosting. So I'm not going into the technical details about all these things. So in case of those who are very much interested in this one, they can contact me. I will give you more details. Now, the classification. How are we going to have task? How we are going to apply? Just I am giving a simple example of information that I have been working on a project. I have tried to model it here. So that is a classification task. We have training set. We have a test set. What we are going to do is, training set is using a learning algorithm. We are going to learn, and we are developing a classification algorithm. This classification algorithm, we are applying a model through a model, and we are trying to deduce what is the outcome classification for a test set that is outside the training set. So this is the seen customers, this is the unseen customers, and the problem is that classification of tax debt customers into can't payers and won't payers. And these are the rules telling which attributes of the customer indicates a can't payer as well as won't payer. I'm not going to detail about what is can't payer and won't payer. Just you just understand there are two classes. Some people don't pay, some people deliberately don't pay. So that is won't pay, so the kind of things. So using that information, these rules have been applied through a model, and we are trying to check these attributes in an unseen data set and say that who are can't payers as well as won't payers. This is how we are going to apply the classification task machine learning tools here. Why random forest? No overfitting, very high accuracy, estimates missing data. For large data set, we can gain accuracy by combining random features with boosting. Variable importance measure, because we can get the importance of each of those variables. And it's a non-parametric, that is no distribution or no assumptions are made here. So in order to train random forest model, in case somebody is interested, because there are a number of packages available in R as well as in Python. It's the carrot and random forest and MLR in R. Scikit-learn, Python, H2O, R, and Python. So these are some of the training models that you can make use of for learning as well as testing the random forest. Okay, so that is the end of my presentation. So now it is time for a question.
Hi, BP, sir. Srini here. Actually, we don't have any questions coming up in the chat. So probably, I think if there are questions, they can shoot it straight to you.
Hello, sir. This is
Yeah.
Deepthi here.
Yeah.
Am I audible? Yeah. I have a doubt. Like, how does this model behave when we have a small data set?
Sorry, your question is not very clear because I have problem in listening to you clearly. That there is no clarity in your voice.
So the question
Hello.
is, how does the model work for a smaller data set?
Okay, smaller data set decision tree is fine. Random forest you can't apply. Just apply one or two trees and see that what is happening. Because in case if you want to apply for a random forest in a small data set, it's not practicable. And also, of course, it is very efficient. There is no doubt in it. But the thing is that you have no sufficient samples to be drawn. Because as I said, each tree in a random forest, we have number of trees. So how are you going to draw number of trees using random numbers? 10, 20 numbers? In case if you have 100 data set, because you have data points are 100. So how many samples you are going to draw? So that is one issue because you don't have sufficient data. But decision tree, that is fine. So not random forest. I would suggest to go for random decision tree rather than random forest when you have small data set.
Thank you, sir.
Yep. Welcome. I have given my email at the end of the slide. So in case if someone is interested, just contact Srini. He will send you the information.
Yeah, all participants, if you have questions, please shoot it directly. You can call, you can talk here.
Hello.
Yep.
Hello, sir. I'm audible.
Yep. Is it Ratish?
Hello, sir.
Yeah.
Mr. Ratish, you're audible.
sir.
Please carry on.
Yeah. Sir, my doubt is that is it possible to combine different classification models together in order to get better results?
Yes, yes, it is possible. That's the ensemble algorithm is there. Because that was one of my MPhil topic was that ensemble algorithm, because number of classifiers, whether it's logistic regression, whether SVM, whether it's deep learning, whether random forest, anything and everything. So all you can combine together. That is what is one of the bagging and boosting two methods of ensemble algorithms that I have talked about random forest. So boosting is one of the things, because when you have very weak classifiers, when you combine together, ensemble algorithm says that you will have a much better outcome. That is synergic impact. So that is possible. Does it answer your question? Hello? Does it answer your question?
Hello, Mr. Ratish.
Sorry, sir. Mr. Ratish has left the meeting.
I think some audio problems.
Hello, sir.
Yeah.
Am I audible? Am I audible?
Yes.
Sir, you said that random forest can predict the missing values. So how is it gonna predict that values?
All right. Say, for example, what happens, in case if we have missing data, but so there are many methods, algorithm that is outside the algorithm, that is a techniques that is available within the random forest method, that there is a imputation method using the random forest technique. So using that one, because in case if you have a missing variable, that missing variable you are taking as a outcome variable, and you are using all of the informations to come up with an outcome variable for that particular outcome variable. That is, your missing variable becomes an outcome variable, and you are running a random forest model for that a particular set of variables using leave out one variable that has missing value, and you are trying to project or predict the missing values on the basis of the rest of the variables.